class, Dr. Barnes here. So we have this question in Laplace transforms. We continue our studies on Laplace transforms. So here we're supposed to solve for this particular signal. Okay, so now we know that Lt of x of t is equals to this into x of what? T. Okay, into Laplace transforms. Okay, into minus s of what? T. Okay, dt. All right. So here, if I should put the original signal into this x of t, then I'm going to place here is minus infinity. Then, okay, first let me equate here to x of what? X, because this is the Laplace transform. Okay. So now here, Lt of x of what? Of x of what? T. Okay, is equals to x of what? S is equals to okay, this one. Okay, so here I can put minus e, okay, minus at into what? U of minus what? T. Okay, of u of minus t into what? E exponent minus st the what? The t. Minus st dt. So here, okay, so what we can do is we can say that this is equals to minus infinity minus what? Infinity. I'm bringing this minus outside. So it will become what? E exponent minus what? At into what? U of what? Minus t. Okay, into E exponent minus what? St the what? The t. Okay, so now let me see the behavior of the signal by plotting this unit step signal. What is the unit step signal? U of minus what? T. That's a unit step signal. So to plot that signal, this is all that I'm going to do. Okay, so here I can call here what? T. And here you see that this signal is what? Minus t. That means that it's time what? Reversal. It's going to the opposite what? Direction. So it will go this particular way. Okay, and here is what? 1. Okay, here I can write u of minus what? T. Okay, and then here I can write x of what? T. Okay, and here is what? 0. Okay, here is 0. So here is minus what? Infinity. And here is what? Infinity. Okay, so this will be the behavior of this particular what? Signal. Okay, so now to put this one into the equation I have, then my equation is now going to become minus what? Infinity. Here the equation, the signal is starting from what? Minus infinity, and it's ending at where? 0. Okay, into what? This minus, I brought it here. Where did I get this minus from? I got this minus from where? From here. Okay, so here I'm going to have E minus what? At. Okay, so now I've already dealt with the behavior of this unit step signal, so I can now ignore it from my equation. And now I can now write what? St. I can just write what? St dt. Okay, I can just write St d what? dt. Okay, and now I can just say that minus infinity, minus into infinity. Okay, minus into integral of minus infinity to what? To 0. Okay, E exponent minus what? Let me write here S. Okay, plus what? A into what? T the what? The t. Okay, so I can, this is what I can actually what? Have at this particular stage. I can straight away go on from here and then do my integration. Okay, but before I do the integration to find my Laplace transform, I want to first find the region of convergence, because it will also help me in my integration. So let me pause here and then finish my region of convergence before I come to continue with the integration to find the Laplace transform. So here, region of convergence. Okay, so region of convergence, which is called what? ROC. So how do I find the ROC? I know that the ROC is what? Integral of what? minus infinity to what? Infinity. Okay, so let's say ROC is equals to this. Okay, into what? Absolute of x of what? T into what? E exponent what? Minus sigma what? T. Okay, the T. Okay, here, let me bring the absolute here. The T, which in this case is going to be equals to what? Here, in this case, my signal is from what? Minus infinity. It's from minus infinity to what? 0. And then this thing is my signal actually is, I have minus here, and I have E exponent what? Minus what? 80. Okay, I will not bring the U of minus T because that is actually giving me the interval which is minus infinity to what? 0. So E exponent minus 80, and the value for unit step signal is 1. So I can ignore that one and then just write it this way. And then here I'm going to have E exponent what? Phi what? T. Okay, sorry, it's minus phi T. Minus what? Phi what? T, which is equals to here minus, okay, minus here, and then here is 0. Okay, so here I'm going to have E exponent what? Minus here. Okay, I'm going to have here what? A plus, okay, A plus what? Phi, okay, into what? T. Okay, so now here is what? The T. Okay, so now what is the assumption in the region of convergence? The region of convergence says that the signal can only converge when I have an absolute what? Integral. The absolute integral means that it should be less than what? Infinity. So this one is equals to here 0 minus what? Infinity. Okay, E exponent minus what? E plus what? Sigma. Okay, into what? Into T, the what? The T should be less than what? Infinity. Okay, so in which condition can this signal be actually be less than infinity? Okay, this signal can be less than infinity. This signal can be less than infinity when I have sigma plus A to be less than, okay, to be less than 0. Why am I saying that it should be less than 0? Because if you look at my graph, it is actually at the negative aspect of the what? X-axis. My graph, it lies at a region which is what? Less than what? 0. That is why I am saying that it should be what? Less than what? 0. Okay, so now here, phi is less than what? If A goes here, to minus what? A. Okay, so now from here, I can draw my S-plane. Okay, so this is my S-plane. Alright, so here is what? Imaginary of what? S. And then here is what? Sigma. Is what? Real of what? S. Another name for the sigma is real of S. Okay, and then another name for omega J is what? Imaginary of S. Here is what? Omega what? J. Okay, here is what? 0. So where is minus A? Okay, here I have sigma less than what? Minus A. Okay, so minus A is a point. Okay, that will lie at the what? The negative side. Okay, that will lie at the negative side. So that means that minus A will be somewhere here. Okay, so I will just draw a broken line through. Okay. Okay, so here S is equals to minus A. Okay, S is equals to minus A. Alright, so now basically let me see in which plane will my region lie. Okay, to know the plane which my region will lie, I have to come back to this unit step signal. So the unit step is lying at the negative side. Okay, that means that it's going this way. So that means that my graph here should also go what? This way. Okay, so this is how my graph will therefore look. Okay, so that is how my graph will therefore look. Okay, so now having been able to finish my region of convergence, so now I can say that my region of convergence, okay, RE of what? S, okay, which is the same thing as what? Sigma, okay, is less than what? Is less than minus what? A. Okay, my RE of S is less than what? Minus A. Okay, so now having been able to determine my RE of S, then I'll have to go on and then find my integration. Okay, so I'll go on and then find my integration. Okay, so from the integration I can determine my what? Laplace transform. Okay, so now here I know that to find the Laplace transform of x of what? T. Okay, which is Laplace transform, which is also called what? S of x, which is equals to integral. In this particular case, my function was from what? Was from minus infinity to what? To 0. Okay, and I had a minus here. Okay, we have already written the equation, so we are just picking from that particular point where we stop. E exponent minus what? 80 into E exponent what? St. Okay, the what? The t. Okay, and then we know that this particular equation is actually equals to what? Is actually equals to here minus what? Infinity to what? 0. Okay, is what? E. Here is minus. Okay, minus. Okay, here I can have s plus what? A. Okay, s plus a. Okay, and then here is, and then what we have here is that here is what? T, and then here is what? The t. Okay, and here is the t. Okay, so this is what we have right now. Okay, so this is what we have right now. Okay, so now if we have this one, then I can just straight away integrate this function. Okay, so how can I integrate this function? Okay, so now I can say that if I'm integrating this, I'm going to have minus the first minus will come, and I'll have what? Minus again. Okay, 1 over what? 1 over s plus what? A into what? E exponent what? Minus what? S plus what? A into what? T. Okay, into t. Okay, all right, so this is basically what I will have, and then here I'll have minus infinity, and I'll have what? 0. Okay, so now if I have this one, then what I can actually say is that, okay, I'll just introduce my limits. So if I'm introducing my limits, this place I'll have what? Positive, because negative, you'll make it what? Positive. Okay, so now what I can just say is that I'll have what? 1 over what? S plus what? A into what? E. You introduce the upper limits first, so E exponent what? 0. Okay, minus E exponent what? The lower limit. Okay, so the lower limit I have here to be what? Negative. And this s plus a is also what? Negative. Why do I call it what? Negative. I call it negative because you can see that from here we said that 5 plus a is less than what? 0, meaning that 5 plus a is what? Negative. Okay, and then also our graph lies in the negative region of what? Of the x-axis. It lies in the negative region of the x-axis. Okay, so that means that here this s plus a is also what? Negative. And then I'll introduce my negative infinity into what? At where t is. So there'll be another what? Negative here. So basically I'll have what? Negative. S plus a is also negative. Okay, and then I'll have negative what? Infinity. Okay, so this is how it will be. So now if I have this, then it's going to be equals to 1 plus s plus what? A into what? E exponent 0. Okay, minus E. 3 negatives is what? A single negative. E exponent what? Minus infinity. So now, please remember that we have E exponent 0 is what? 1. E exponent minus infinity is what? 0. And then E exponent infinity is what? Infinity. Remember this. Okay, so now when we have this, then we're going to get here 1 over what? S plus what? A into 1. Okay, minus what? 0. Okay, so I'm going to have x of what? S is equals to what? 1 over what? S plus what? A. So this will be the Fourier transform. This will be the Fourier transform. So now this will be the Laplace transform. So now the Laplace transform of what? E minus E exponent what? Minus what? At into what? U of what? Minus t is equals to 1 over what? S plus A. Or you can also write it in this particular format, that minus E exponent minus what? AT into U of what? Minus T has a Laplace what? Transform of 1 over what? S plus A. So this is the end of this question. And then this Laplace transform occurs at the real what? Axis, real of S, okay, which is less than what? Minus what? A, okay, the real axis, which is actually less than minus A, which you can also write here, less than what? Minus A. So that's the end of this question. See you in the next lecture.